Let's talk about output components, keyboard or keypad. Keypads are mechanical devices to execute a break or make connection between 2 points. Basically, they are like a switch that is arranged in a matrix form or in an array of lineup. It comes in different sizes and different purpose, soldered directly onto a PCB, and are often found in electronic devices. When the key press, two contacts are joined together and connection is made, basically like a switch, push button switch. The problem lies in the nature of voltage as an electrical dimension and the imperfection of mechanical contacts. Not really a problem actually. It's actually the nature of the material, and we took advantage of it and make it something useful. Keypad 4x4 type A, you have these arrangements 1, 2, 3, and then A, 4, 5, 6, B, 7, 8, 9, C, and so on. The keyboard in an array switches where 2 wires are connected. Each time button is pressed, the keypad pins need to be pulled up or pulled down to avoid floating case. The key press depends on the matrix of row times row by column. So if you can see here, we have the circuit connected to 5V VCC, and then we have row 1, row 2, 3, and 4, and then column 1, 2, 3, and 4. So they are only connected if there is a button press or the keypad press. For example, like these ones, row 2 will receive a 5V when the button or the keypad is pressed. And then an example of application of keypad and LCD using the PIC 16F84. So you can make use of this keypad connected to PIC. Basically, it uses the whole port B there and some of port A. It depends on how the way you configure it. You could also have another devices like this one, an IC 4094, which controls the data that goes into the LCD. Okay, this is one of the possible ways, but we're not going to go into detail for this type of connection. Next part is the output components, is the motor. Motor is an output component that converts electrical pulses into mechanical movement. There are several types of motor. We have a DC motor, AC motor, servo motor, stepper motors. For DC motor, there are only 2 leads, one positive and the other one is negative. It will rotate continuously when connected to a DC source. The direction of movement is based on the polarity of the voltage source connected to it. Maximum speed is indicated in the datasheet in rotation per minute RPM, and no load RPM and loaded RPM. Each DC motor has its own voltage rating and current rating. Alright, however, if the voltage increases, the RPM also increase. Alright, this is the fundamental operation of a motor. I'm not going to go detail into this. This is actually covered in another topic. Sorry, another subject. So what is of my concern here is the direction of motor. So if you change the power supply polarity, okay, like this one, you will have different motor direction. For example, in this case, the positive is on at the top, negative at the bottom. So the motor will run, let's say this way is clockwise. And we change the polarity of the battery or the supply, it will goes to counterclockwise. All right, so if you want to keep on changing clockwise or counterclockwise of the motor, you could use this way of switching it. For example, this is the battery will still be the same, plus and minus, except that the direction of the currents will flow according to the switch position. So in this case, let's say you have a switch 1 and switch 4 is on, meaning the current will flow from here through the motor and then, all right. So that is the first position. Okay, let me erase that. And the second is switch 2 and switch 3 is closed, meaning the currents will flow through here and out through switch 3. So you will have a different, the motor itself will experience different polarity. So this one, the positive is here, negative is here, and previously the positive was here and negative was here. So it depends on the switch position. So this is this technique is already easily implemented using H-bridge operation. You can have like a truth table here. H-bridge will control the direction of current through the motor. Okay, in this case you have switch 1, 2, 3, 4. Okay, switch 1, switch 2, switch 3, and switch 4. So this is like a truth table. Like I mentioned just now, clockwise when you have switch 1 is on and switch 4 is on, and whereas the rest are turned off. Counterclockwise you have switch 2 is on and switch 3 is on and the rest is off. And then if all of them are turned on, then it's an invalid operation. By right, if you do this physically, let's say you turn on switch 1 and switch 3 simultaneously, what do you think will happen? Basically, if you do this, basically it's gonna be like a short circuit, which will drain out the battery or it will damage your power supply. So H-bridge have its sort of own protection when these things happens. Okay, and it will just show an invalid operation. It will not short circuit your circuitry. Okay, like I have mentioned just now, clockwise direction, you can see it here on the left. It's like the positive here, positive here, negative there, and then counterclockwise direction, positive is on the right, negative is on the left. Okay, H-bridge, it acts basically like a relay. Okay, it can be created using relay and transistors, but the convenient solution is to use single IC called a direct motor driver. It provides up to 2 amps of current for each output. Okay, so here we have three wires, or three lines, or three connections that you can make from the microcontroller. The first one is enable pin, and then in 1 and in 2. So for the use of motor, you have to have at least three pins from the microcontroller. So from microcontroller, we'll go into these 3 pins to the H bridge. The first one, let me look through this diagram. Supply 12 volt or whatever the voltage required for the motor. So we have here Arduino microcontroller connected to input pin, and then this output pin goes to the motor directly. Okay, you have output 4 here, and then output 3 here. Okay, take note of the connection, and then input 3 from the microcontroller, and enable is either PWM input or whatever signal input that you need. So this one's on the right side is one motor. Okay, the one on the left is another motor. Okay, this one's here. So the input is basically enable here, and then in 1, and then in 2. Okay, they are explained in this truth table. And this is how you can do the simulation in Proteus. So if you were to use single motor, this is how the connection is made. So in 1, in 2, and enable comes from whatever the port that you want to use from the PIC microcontroller, and the output goes to the motor. Okay, L293D, you can have a maximum up to 2 set of motors to be controlled. This is an example of code, program code using assembly. Similar concept if using a C language. Okay, first of all, you have to initialize, and then you perform the motor operation. Let's go through each of these. In the main program, bank cell TRISB is just to select the register TRISB. Move 00, you set port B as an output, and then bank cell port B, move LW80, move the port B. So you are sending, in this case port B, you're sending 10000000. Okay, what's the purpose of that? Let us see what is let's look at the circuit connection. We'll check that later. This is initialization. By right, according to this circuit, B0 is here, so you send enable here. All right, 10000000. Sorry, another 0. Okay, so when you send the data 80, this is what happened. Okay, so you initialize, meaning you're sending, you turn on the enable pin. Okay, and then motor operation start, bit clear F, port B, pin number 5, meaning this one is set to 0, and then bit BSF, port B, pin number 6, this one sets to 1, called delay. Okay, and then BCF, port B6, and you set to 0, BSF B5, set it to 1, call delay. Okay, right. So if you notice, the enable for this example, enable pin is always on, and then you set the motor direction clockwise or counterclockwise by setting the pin, okay, 1 or 0. And then you call for delay. Right. Next is the switch debounce. What is debounce? Debounce is like a bouncing effect. Like in this case, when you press a switch, you know, the switch position is a mechanical position. So when you press the switch, okay, this point, when it's about very close to this contact, this is in a very small time difference. You see, it's like either microseconds or milliseconds. So by the time when you press the switch, when it's almost making a contact, it will be like an intermittent state where it can detect as on or off. Okay, on or off, on or off, until the switch is fully pressed. So during these times, the system will interpret, make a false interpretation whether whether the switch is pressed or depressed. So you cannot make a decision based on you know, because the microcontroller can process this even a tiny difference, I mean a small time frame. So in order to process this thing, you should process it here, meaning after the switch is fully firm in its position. Okay, this is because of a mechanical contact. Okay, push button switch, toggle switch, electromechanical relays, they all have the same issue. So the metal contact can break the circuit and carry the current in switches and relays. So it has a mass and springiness with low damping, and they will be bouncy as they switch on or off. Okay, it is also called the contact bounce or the switch bounce. Alright, how to eliminate that switch bounce problem in the circuit? There are two ways. You can use hardware solution, and then you can use the software solution. Hardware, to use a hardware, you have to use you can use a RC time constant. With this kind of circuitry, you have the R and C here. So meaning when you press the switch, the bouncing effect will be eliminated by the capacitors and resistors. Multiply resistance value and capacitance value to get RC times constant. The typical value is 0.1 second or 100 millisecond. So anything that bounces, okay, less than 100 millisecond is not recorded in the microcontroller. Buffer is used to produce sharp high to low transition. Use time constant to ensure double tapping can also be eliminated. Right, hardware, there are some advantage. The advantage is that it's easily implemented without worrying software bug. But if you need more of this for each pin, then it will be a bit of a hassle, because you need to design that PCB with lots of a lot more components. And the issue is with a lot more components, you need your production cost will be increased tremendously. And then if you have lots of application, I mean the use of debounce switch for the input, what you can do is using software. The advantage of using the software is that you don't have to have the cost of hardware, meaning your cost is lower. Okay, by using software, you design the program to include delay long enough to allow the contact to stop bouncing. Meaning what happens here is you let's say you have a switch. Oh, sorry. Let me delete that. You have a switch press. Okay, this will happen. All right. So you don't read at this point. You put a delay and you read at this point number 2. Okay, so put a delay long enough to allow the contact stop bouncing, and then only after that time frame then you read the input. However, switches and relays can lose some of their springiness as they age. This can cause time it takes to contact stop bouncing to increase with time. Okay, the age effect. So the debounce code that worked fine when the keyboard was might not work a year or 2 later. So that's basically it, the end of chapter 5. Thank you for watching. Don't forget to hit like and subscribe, and leave a comment in the section below.